Hello friends, welcome to my YouTube channel. My name is Prathamesh. Without wasting our time, let's begin. And if you like, please like, share, and subscribe.
For decades, the primary way we've navigated computer interfaces has been through a purely geometric tool, the cursor. An operating system calculates the mouse's movement by tracking its path across a rigid XY coordinate grid. But this model lacks awareness. While it knows absolute location, it receives no semantic data. To the OS, text, images, and tables are indistinguishable blocks of pixels. This means the human user must serve as the primary cognitive bridge. You are responsible for identifying relevant data and moving it between disconnected applications. This gap is particularly visible in current AI workflows. Using an AI model today requires a repetitive manual cycle, identifying the relevant data, manually copying the text, opening a separate browser window, and pasting it into chat. This creates prompt friction. The user is forced to spend time writing out visual context in text form just so the AI understands the image. Google DeepMind is testing a solution called Magic Pointer, an experimental AI-enabled mouse that aims to remove the need for this manual data transfer. The core architectural change integrates the Gemini model directly into the cursor's behavior, turning it into a spatially aware sensor. By establishing contextual intent at the operating system level, developers hope to eliminate boundaries between the user's view and the AI's processing power. The Magic Pointer operates by treating the computer screen as a connected semantic node graph. This relies on a capability called multimodal context understanding, which allows the cursor to analyze the digital environment in real time. As the cursor moves, it differentiates between objects. This diagram shows bounding boxes snapping to specific types, recognizing text, code, maps, and images. Because the underlying model continuously ingests this information, the user no longer needs to provide manual inputs to start a task. The system takes over the burden of context gathering, allowing the AI to maintain an ambient awareness of the entire screen state. This spatial awareness enables spatial visualization, which uses the cursor's coordinates to anchor generative AI tasks to a specific spot on the screen. For example, an interior designer points at an empty corner in an image of a room and requests a specific piece of furniture to be placed there. The cursor provides the geometric anchor point, while the AI interprets the surrounding image to match the existing perspective and lighting. Successfully executing this requires a hybrid approach. The system must solve for both the rigid mathematics of geometry and the creative nuances of image generation. Human communication often relies on deictic phrasing, using words like this or that while pointing at an object to provide context. Magic Pointer brings this to the interface through intent-based voice commands. Instead of writing a prompt, the user simply points at an object and speaks a command. Consider the steps required to build a comparison table from a retail site today. You would have to manually copy the price, name, and specs of every item into a document or a separate chat box. With a spatially aware pointer, the process is streamlined. You drag a selection box across products and say, "Merge those." The diagram shows separate item nodes collapsing into a unified table, automatically populating columns with inferred prices and materials. Using voice intent instead of text prompts condenses the workflow, shifting the user from a data entry clerk to a director of automated actions. Most computer programs are isolated silos. Data usually stays trapped within the specific application that created it. Magic Pointer bridges these gaps by extracting contextual entities from live media, regardless of which application is running. If a video shows a restaurant, it pulls the location data, generating a browser booking link. Point at an email, it identifies unstructured dates, converting them to calendar events. The cursor functions as a universal semantic bridge, allowing data to flow between applications without the need for custom integrations or APIs. Performing this kind of real-time analysis at the OS level requires hardware that can communicate active AI processing to the user. New laptops, branded as Googlebooks, are scheduled for release this autumn through partners including Acer, Asus, and Dell. These machines include a physical glow bar built into the chassis. This light serves as a clear indicator, notifying the user exactly when the Magic Pointer is scanning and analyzing the contents of the screen. For those who want to test the software now, Google Chrome Beta has released an experimental version that allows for these types of page interactions. When an operating system is capable of monitoring everything on your screen, hardware-level indicators become a necessary standard for user privacy and transparency. Placing an experimental large language model at the center of your navigation system introduces new risks. Even with advanced contextual awareness, these AI systems remain fallible. This visualization illustrates how data logic can warp. While the pointer makes tasks faster, its interpretations can be wrong, leading to hallucinations or misinterpreted commands. Human oversight is still the most critical part of the workflow. Users must verify the accuracy of every generated response and calendar link. The magic pointer transforms the cursor into a semantic assistant.
Opening 20 different tabs just to buy a new laptop or compare headphones is exhausting. We end up jumping back and forth across browser windows, trying to hold different specs, prices, and reviews in our heads all at once. Google DeepMind is testing a solution called the magic pointer. This takes the traditional arrow cursor on your screen and turns it into a luminescent sensor orb powered by their Gemini AI. To use this experimental tool, you need specific setups. Right now, it requires running Google Chrome Beta with Gemini enabled, or using one of the upcoming Googlebook laptops releasing this autumn from partners like Dell, Acer, and Asus. This split-screen mockup shows the goal. We want to take a chaotic grid of products on the left and instantly generate a clean, side-by-side comparison table on the right. We will do this without opening new chat windows, typing out long prompts, or copying and pasting text.
By removing the friction of manual data entry, your role changes. You stop doing the tedious work of copying specifications, and you start making the final purchasing decision based on neatly organized information. Step 1 is the setup. Navigate to the retail webpage containing the products you want to compare, and verify that the AI assistant is actively monitoring the screen. If you are using a new Googlebook laptop, look for the physical glow bar. When this light is on, it indicates the AI pointer is actively analyzing the contents of your display. This brings us to a process called multimodal context understanding. Because the AI is integrated directly into the cursor, it simultaneously reads various types of visual and textual data based on exactly where you are pointing. Look at this wireframe overlay. As the cursor hovers over the page, it identifies and categorizes specific elements. It reads the descriptive text blocks, processes the product images, and extracts the numeric prices. Because the AI actually sees the screen exactly as you do, you no longer need to switch to a separate chat box to explain what you are looking at. The cursor's position provides all the necessary context. Now for step 2. Click and drag the magic pointer directly across the specific subset of products you want to compare. This vector grid demonstrates how spatial selection works. By dragging the cursor, you create a highlighted bounded box that isolates your 3 target objects. This tells the AI to focus its attention strictly inside this defined area. A common mistake is highlighting the entire web page rather than just the specific items you need. Notice what happens when the selection expands to include background noise. The target objects immediately dim and lose focus. Capturing unrelated banners dilutes the AI's accuracy. Precise spatial mapping is how you control the quality of the final output. The physical box you draw acts as a strict filter, ensuring the AI only processes the exact data you want compared. Step 3 transitions your workflow. Once you have drawn your precise physical selection over the products, you immediately follow up with a verbal instruction. Simply speak a concise command out loud, such as, "Compare these products in a table." DeepMind calls this intent-based voice commands. This feature links the spatial context you just established with your mouse directly to the final action the AI will take. As you speak, the system provides visual feedback. The physical glow bar on your laptop lights up, indicating the system is actively analyzing your request. By coupling a simple spatial gesture with a brief verbal command, you successfully bypass the traditional bottleneck of writing out long descriptive text prompts. Step 4 is the output. Almost immediately, the final comparison table generates, overlaying directly onto your original retail screen. This mockup displays the generated AI comparison table. It cleanly extracts prices, organizes physical dimensions, and aligns user rating categories side by side for easy review. However, whenever AI rapidly extracts specific numeric specifications, there is a risk of AI hallucinations, where the system simply invents incorrect data. Therefore, step 5 is the mandatory human audit. You must cross-reference a specific generated price in the table against the original source webpage to verify the AI's accuracy. The AI accelerates the organization of data, but ultimate analytical authority and factual verification must remain permanently with you, the human user. Generating an e-commerce comparison table is just one specific application of using the cursor as a contextual sensor. This technology applies directly to daily task automation. For example, by pointing the cursor at a list of dates inside an email, you can instruct the system to instantly generate corresponding calendar events. It also applies to visual design. If you are looking at an image of an empty room, you can point at a specific location and ask the AI to visualize new furniture. The 3D couch smoothly materializes right where your cursor is resting. To experience this integration firsthand, your immediate next step is to download the Google Chrome beta. By connecting the cursor's location directly to the AI's processing, the system removes the need for descriptive prompts, allowing the software to infer your intent from the data you are already looking at.